Now my dear students, we can see here question number 13. P and Pb are the vapor pressure of pure liquid components A and B respectively of an ideal binary solutions. If XA represents the mole fraction of component A, the total pressure of the solution will be. Here my dear students, we can see here concept and formulas. Theory, concept and formulas. Concept in this question. My dear students, P total, always you can see here P total is equal to Pa plus Pb, because here two pure liquids are present in a solution. So, partial pressure of A plus partial pressure of B, that equal to P total. Now, my dear students, here this partial pressure that equal to pure vapor pressure of that liquid into mole fraction of that solute. What is the Pb? My dear students, Pb is the pure vapor pressure of that solvent or solute and mole fraction of that solute or solvent. Now, when we can put the two liquids, then that is the mole fraction of that liquid. So, my dear students, when you put these values in this formula, then you can get the P0A into XA plus P0B into XB. Now, we can see here, my dear students, P0A into XA and P0B into XB. What is the X and what is the relationship between XA and XB? Here we can see that XA plus XB, that equal to 1. So, XB is equal to 1 minus XA, you can say here. So, we can P total is equal to P0A into XA plus here P0B into, in place of this XB we can put the 1 minus XA. So, you can get the P total that equal to P0A into XA and P0B minus P0B XB. P0A into XA plus P0B into minus P0B XA. So, my dear students, you can here P total is equal to PV P0V plus, you can write in this way, P0A minus P0V into XA. Because this XA is multiplied with this P0A, you can get this P0A XA. When this is multiplied by this P0V, you can get the minus P0V XA and minus P0B into XA, you can get here. So, my dear students, this equation is right in this way, and when you can write this equation in this way or in this term or in this form, then you can get the answer. Because here question number 13, you can get the answer D. In D, same equation is present, XA multiplied P0A minus P0B. Now, my dear students, we can go to the question number 14, and this question is also as in MENT 2012. Here, my dear students, vapor pressure of chloroform and dichloromethane at 25 degrees Celsius are 200 millimeter mercury. Vapor pressure of the solution obtained by mixing 25.5 gram of chloroform and 40 gram of CH2Cl2 at the same temperature will be. Here, my dear students, in this question, we can solve in this way. First of all, we can see the which are given in your numericals. Here this vapor pressure of pure chloroform is given, and my dear students, it is the 200 millimeter mercury. Here you can see the vapor pressure, pure vapor pressure of CH2Cl2 is also given, and that is 41.5 millimeter mercury. And my dear students, you can also know that what is the moles. Moles is equal to W upon M, because when we calculate the mole fractions, because here in the vapor pressure mole fraction is also given in the formula, in the mole fraction you can take the moles, and here moles are not given directly in this numerical. Here you can see the grams are given in the numerical. So, these grams are divided into or convert to moles, because here molecular masses are also given. So when you can calculate the moles of this chloroform, then W is equal to 25.5 is given in the numerical upon 119.5 is also given in the numerical. It is a molecular mass of chloroform. When, my dear students, you can divide this, then you can get the, my dear students, 0.213. Now we can calculate the moles of CH2Cl2 dichloromethane. Same formula is used, W upon M, and W is given, that is 40 gram for CH2Cl2, and molecular mass is also given in your numerical, that is 85. So when, my dear students, you can divide both and division of the 40 upon 85, then you can get the 0.470. Now we can here get the X of chloroform, because when we calculate the vapor pressure, X must be known. So X of chloroform, that equal to number of moles of chloroform and chloroform, and divided by the N chloroform plus N CH2Cl2. So my dear students, you can put these N values. N chloroform, that is 0.213, this is 0.213 plus 0.470, and you can get the, my dear students, that is the N chloroform, that equal to X is equal to 0.31. In this way, you can also calculate this X CH2Cl2. When, my dear students, you can calculate the X CH2Cl2, then it is a N CH2Cl2. N CH2Cl2 is a 0.470 upon N CH2Cl2 is a 0.470 plus, you can plus 0.213. So you can get this mole fraction of this compound is 0.69. Now, my dear students, you can calculate in this all the moles and mole fractions. Now we can put the here formula and put the values. Here, my dear students, we can see here P total, that equal to P0A into XA, X for this chloroform, plus P0V into X for CH2Cl2. So my dear students, you can calculate the P total. Here P total we can calculate it, not given in this question. He wants you calculate the P total, vapor pressure of solution. So P0A, that is 200 multiply by the X chloroform, you can calculate 0.31 plus P0V CH2Cl2, that is 41.5 multiply by the X CH2Cl2, that is 0.69. So my dear students, you can calculate the P total when you can multiply these values and add these values. Now my dear students, you can calculate the 90.63 millimeter mercury, and you can see in this your question, this value is not given, so answer is none. Perhaps this question is cancelled in 2012. But concept, I am giving you a concept and theory. How can solve this type of questions? I am giving you. You can solve in this type of questions in this way. So question number 14, answer is none. And now we can go to the question number 15. A solution has 1:4 mole ratio of pentane to hexane. The vapor pressure of pure hydrocarbon at 20 degrees Celsius are 440 millimeter mercury for pentane and 120 millimeter mercury for hexane. The mole fraction of pentane in the vapor phase would be. Here my dear students, what is the concept of this question? Here you can see concept and formulas. You can see the concept and formula. Here number of moles and pentane. Pentane means C5H12 because here ratio is given upon N C6 hexane. Two hydrocarbons are present in different ratio, N pentane and hexane and C6H14, and this ratio is, my dear students, 1/4. Now we can calculate the mole fraction of this X C5H12. What is the mole fraction? Number of moles of pentane divided by the total number of moles. And what is the total number of moles, my dear students? It is a pentane plus hexane. So 1/1 for pentane, then 1 for pentane and 4 for hexane. So here, my dear students, you can see the mole fraction of pentane that equal to 1/5. In this way, you can calculate the mole fraction of hexane C6H14, that is the mole number of moles of hexane 1 upon number of moles of hexane that is equal to 4 upon number of moles of hexane, that is 4 total number of moles, and pentane 1. So you can get the 4/5. 4/5 is the mole fraction of hexane, 4/5. These are the mole fractions present in solutions. Now, my dear students, we can calculate the total pressure, P total. P total we can calculate. What is the P total? You know very well. P total, P0 vapor pressure of X, you can see here pentane mole fraction, plus this is the P0 for hexane and X mole fraction of this hexane. Now we can put the values. Here what is the pure vapor pressure of pentane, you can see in your numerical. Here 440 millimeter mercury for pentane. So you can put the value 440, and to put the value of this mole fraction of pentane 1/5. Pure vapor pressure of hexane, that is 120. You can put here 120 multiply by mole fraction of hexane 4/5, and you can calculate the P total. So my dear students, here when this is multiply of this and this, you can calculate the P total, that is 184 millimeter mercury. Ratio, now we can calculate the here mole fractions of different pentane and hexane. After this, we can put this formula, this P total formulas, and in this P total formulas, we can calculate the P total. Now, my dear students, when you can calculate the P total, then by the Raaon's law, we can apply the Raaon's law. What is the Raaon's law, my dear students? By Raaon's law, pressure of C5H12 pentane, that equal to vapor pressure and XA P0 of C5H12 into mole fraction of C5H12. This is our first equation. Now this X mole fraction of C5H12, it is a mole fraction of pentane in solution. It is a mole fraction of pentane in the solution. Now, my dear students, we can see here by Dalton's law. By Dalton's law, here pressure of C5H12, that equal to mole fraction of C5H12 X dash into P total. This is the equation number 2. This X C2H5, it is the mole fraction, it is a mole fraction in the vapor phase. X dash is the mole fraction in the vapor phase of pentane, because here you can you can ask what is the mole fraction of pentane in the vapor phase, and in this by the Dalton's law you can calculate PC5H12 and X dash is the mole fraction of pentane in vapor phase and P total. Now my dear students, from 1 and 2, when we can take the 1 and 2 from equation 1 and 2, here this is the equation number 1 and here this is the equation number 2. We can see here PC5H12 pentane that equal to 440 into 1 upon 5, we can put this values 440 into 1 upon 5 and you can get this, that is the 88 millimeter mercury. Now my dear students, we can here see that equal to X dash C5 H12 into 184. So X dash C5 H12, you can see the 88 upon 184. So you can get the answer, that is 0.478. It is the mole fraction of pentane in vapor phase. My dear friends, what is the 88? Here 88 is the partial pressure of C5H12, it is the 88. What is the 184? 184 is the total pressure, P total. So you can write here, that is the P total, that is the 88, and this P total is divided by this P0 and X, P0 and X 12. So you can get the vapor pressure of pentane in a vapor phase, and this is the 0.478 and your answer is D. My dear students, here you can see the 4 types of different concepts. Number 1, here you can see a solution has 1:4 mole ratio pentane. So you can write here mole ratio 1:4. Now here this mole fraction is given and you can calculate by this moles. After mole fraction you can calculate the number 3rd, that is P total, and after this P total you can calculate the use of this Dalton's law, you can calculate this mole fraction dry state. In mole fraction dry state, my dear friends, here mole fraction, this P0 into X C5H5, this 440 into 1 upon 5, here this is a P0 into XA is divided by, means total P0 into XA which is present in solution divided by the total pressure, then you can calculate the vapor pressure, this mole fraction in vapor phase of that substance, and you can get the 0.478. So now my dear friends, you can use this 5, 4 and 5 formulas and you can get the answer. So this question is asked in NEET 2005. I hope my dear friends, these concepts you can see and how can solve these questions you can see. Now in this type of question you may solve. Now we can go to the question number 16. Now my dear friends, we can go to the question number 16 here. We can see the concept and formulas for this question. Here we can see the vapor pressure of 2 liquids P and Q. Here we can see the 2 liquids P and Q are 80 and 20 torr, 80 and 60 torr. And you can see what is the unit of torr, that is the 1 torr is equal to 1 atmosphere. 1 torr is equal to 1 atmosphere. So my dear students, you can see here 1 torr is equal to 1 atmosphere. Here P and Q are 2 different liquids. The total vapor pressure of solution obtained by mixing 3 moles of P, here 3 moles of P, we can take the 3 moles of P and 2 moles of Q. So he want the total vapor pressure. You see P total, that equal to P0 A or P0 into mole fraction of xp plus, my dear students, P0 for that Q and mole fraction of xq. Here P0 is given us 80 and this is the mole fraction. Mole fraction, you can see the number of moles of P. Here it is given 3. Total number of moles 3 plus 2 5 in the solution plus P0, it is given in 60, multiply by the mole fraction, number of moles of Q divided total number of moles. Now we can, my dear students, we can solve these values 80 into 3 by 4 plus 60 into 2 by 5. Then, my dear students, you can solve this question and you can get the P total. And what is the P total, my dear students? That is 72 torr. So, your answer is A. Question number 16, answer is A, 72 torr. It's a very simple question because here moles are directly given in this question. Pressure is directly, partial pressure is directly given in this question. Here weight is not given. So, my dear students, you can only calculate the P total, you can easily calculate. This question is also asked in 2005 NEET exam. Now, we can see here, this is a theoretical question. Question number 17, it is asked in NEET 2020, NEET 2020 exam. The mixture which shows positive deviation from Raaon's law. What is the concept, my dear students? Raaon's law, those molecules, those solutions in which when we plot the vapor pressure and mole fraction graph, mole fraction, here vapor pressure, here mole fraction. You can see the straight line is obtained for the ideal solutions. And this graph shows the, here this is the P0A, if here xa is equal to 1 and xb is equal to 0 and here xa is equal to 0 and xb is equal to 1, then it is the P0V. My dear students, when we increase the concentration of B solution and decrease the concentration of A, then you can see here, you can get the PV is equal to P0A into XA and you can get the straight line. In this way, you can also get the straight line, and in this way, you can go to concentration of B is decreases and concentration of A is increased up to 1, then you can get the here PV, here you can see the PA is equal to P0A into XA. Now, it is, my dear students, let us say P total that equal to PA plus PV. Those solutions which get this graph are called ideal solutions. These are ideal solutions. Here you can see, my dear students, vapor pressure is present of the solution. Here this is the solution and vapors are developed above in the solutions. So, it is called the vapor pressure. This pressure exerted on the liquid surface when condensation and vaporization process are in equilibrium. That pressure is called vapor pressure. Here in ideal solution, you can get this type of vapor, but in positive and negative deviation, when you can see the positive deviation. Here, my dear students, positive deviation, vapor pressure is present in this way, your graph is present in this way. Positive deviation means your graph is present increase graph. Here this is the increase from this normal graph, and graph is this, graph is this, and graph is straight lines. But here you can see the, for positive deviation, your graph is present in this way. And what is the negative deviation? My dear students, I can explain in this question, and when you can get the negative deviation question, we can easily understand. Here total pressure in negative deviation, my dear students, you can get negatively. Here you can get this negatively deviation. This is a negative charge. It is a negative chart you can get. So, my dear students, here this is a negative deviation, and you can see the here the positive deviation. Now, my dear students, in positive deviation, vapor pressure of the solution is increases when you can add the A plus B solution. Vapor pressure is increasing. Why this vapor pressure increases, my dear students? It means in solution intermolecular forces are greater in solution when the solution A and B intermolecular forces are greater. But when we added two molecules A and B, intermolecular forces are less. So these molecules go in the vapor form and form the vapors, and it is called vapor pressure is increases. In this way, when vapor pressure is increases, you can get this type of graph. It is called positive deviation from Raaon's law. Now here, which compounds give this positive deviation, my dear friends? Those compounds give positive deviation in which intermolecular forces are less when mixing with each other. Now in question number 17, we can see here answer is A. Here when this, you can see the ethanol and ethanol. In ethanol and ethanol, C2H5OH and C2H5OH. This is the A and A. Intermolecular force is greater. But when you can add this ethanol, then chloroform or acetone, ethanol with acetone. What is the acetone, my dear friends? CH3COCH acetone, A and B. Intermolecular forces are less. When intermolecular forces are less, my dear friends, why? Because here you can see the hydrogen bonding is present and here no hydrogen bonding is present. So these molecules are easily go in the vapor form and increase the vapor pressure. So vapor pressure increases means total pressure is increases, and total pressure is increases, P total is also increases, vapor pressure is also increases. So my dear students, answer is your ethanol plus acetone, and this question is asked in NEET 2020. Now we can see the question number 18. Now we see the question number 18. In this question number 18, for an ideal solution, the correct option is, this question is also asked in NEET 2019, means 2019. My dear students, what is the ideal solutions? Ideal solutions are those solutions which obey Raaon's law. This is the concept. Ideal solutions are those solutions which obey the Raaon's law. In ideal solution, my dear friends, delta H is equal to 0, delta V is equal to 0. These are 0 for ideal solutions. So my dear friends, you can see here, ideal solutions are formed by example benzene plus toluene, or second example is, this is the number one example. Number second example is C2H5Cl plus C2H5Br. So my dear friends, these are formed ideal solutions. So your answer is D, question number 18, because delta H is equal to 0 and delta B is equal to 0 in ideal solutions. This question is asked in NEET 2019. Now my dear friends, we can go to the question number 19. My dear friends, the mixture that forms maximum boiling isotope. What is the concept of this question? Boiling isotope, isotopes mixture is called, my dear friends, constant boiling mixture. It is called constant boiling mixture, and when you can see here maximum boiling point is present, then it is called higher boiling point mixture. Higher boiling point mixture is called maximum boiling isotope. Is called maximum boiling isotope. Here, my dear friends, when you can see the water and HNO3, boiling point is different. In water 100 degrees Celsius and nitric acid lower than 100 degrees Celsius. But when both are mixed together, it forms the maximum boiling point azeotrope. Means boiling point of HNO3 and water are constant, and at that boiling point both are converted to vapor form. So, my dear students, this type of mixture is called azeotropic mixture. So, question number 19, you easily go to option B, water plus HNO3. I suggest you, my dear students, you can learn the example which gives the maximum boiling azeotrope and minimum boiling azeotrope. These are the examples which are given in your NCERT books or your text. My dear students, after this question number 19, you can see the question number 20. Which of the following statement is correct regarding a solution of two components A and B exhibit a positive deviation from ideal behavior? I can give you what is the positive deviation. Positive deviation is given by those components in which intermolecular forces are less. So, my dear students, your answer is A, and this answer is already discussed by me. Question number 20, answer is A. Now, we can go to the question number 21. Which one of the following is incorrect for ideal solutions? My dear students, this question is also asked in NEET 2016. In this question, in ideal solutions, free energy never will equal to Z. So, my dear students, you can go to the question number 21, option is D. Free energy is the change in energy in which maximum work done by the system, or we can also see that free energy is the available energy of the system to do useful work by the system. This is the definition of free energy. Now, in ideal solutions, delta G mix never be 0, may be 0, enthalpy, internal energy may be 0 at delta P, change in this pressure that equal to 0, but this is not 0. So, my dear students, delta G is the change in free energy, and free energy is the available energy of the system to do useful work by the system. Now, we can go to the question number 22. Which of the following statement about the composition of the vapor over an ideal 1:1 molar mixture of benzene and toluene is correct? Assume that the temperature is constant at 25 degrees Celsius. Here, my dear students, we can see the vapor will contain equal amounts of benzene and toluene. Here, he wants the composition 1:1 means ideal solution. He wants the ideal solutions. My dear students, not enough formation is given to make a prediction, and the vapor will contain a high percentage of benzene. Yes, this is the correct answer, because here pressure of benzene is 12.8 kPa and toluene is 3.85. When you can increase the pressure, vapor pressure, you can get the more vapor pressure, it means vapor will contain higher percentage of benzene in the vapor. So, this benzene gives a higher vapor pressure. So, by this data we can see that vapor will contain a higher percentage of benzene, because here we can see the higher vapor pressure. So, my dear students, question number 22, you can go to the answer C, and this question is also asked in NEET 2016. Now, we can see here question number 23. In this question number 23, my dear students, which condition is not satisfied by an ideal solutions? Ideal solution, you can see that delta H is equal to 0, delta B is equal to 0, and obeys to Raoult's law. This is also, my dear students, here correct, but he said they are not satisfied. So, my dear students, ideal solution condition is not satisfied, that is B. Delta S, my dear students, it is a change in free energy, change in entropy. Change in free energy means change in entropy, not free energy. Free energy changes delta G, it is a change in entropy, and change in entropy is not equal to 0. So, change in free energy is not equal to 0 in ideal solution. So, my dear students, both are not equal to 0, and these are in NEET 2013. And what is the entropy, my dear students? You know what is entropy? Entropy, my dear students, entropy is the measurement of randomness. Means when you can see the solid, entropy is less because these atoms are present in a fixed manner. In liquid, you can see the entropy is increases because this fixed manner is not present, and in gas you can see the entropy is maximum increases. So, in this way you can see the entropy is increases when you go to the gas, liquid and solid. So, my dear students, in ideal solution entropy is not equal to 0, it must be increases. Now, we can go to the question number 24th. A solution of acetone in ethanol. This question is also asked, and we can take in detail. This question is asked in 2006, and we can already discuss this question, acetone with ethanol. In the option, you can see that when this ethanol is added, with acetone, here this A and B hydrogen bonding is less. So, my dear students, when we can see the hydrogen bonding present in ethanol and ethanol or acetone, or we can see the intermolecular forces, forces of AA is greater than AB. So, my dear students, when you can mix the ethanol and acetone, vapor pressure is increases. So, it does not obey the Raoult's law and show the positive deviation. So, my dear students, you can go to the question number 24th. Answer is C, and this question is also in 2006 NEET exam. Now, we can see the question number 25. A solution containing component A and B follows Raoult's law. Here we can see the AB attraction force is greater than A and BB. Here solution containing components A and B follows Raoult's law, because those solutions follows Raoult's law are ideal solutions. When forces is greater means negative deviation is present, not obey. Attraction force is less means positive deviations occur, not obey. And when remain is same, so my dear friends, you can go to the question number 25 C option, because in C option this is forces are same, so obey the Raoult's law, and these are the ideal gases or ideal solutions. Question number 2002, you can get the answer. Now, my dear friends, we can go to the question number 26. All form ideal solutions except, my dear friends, those solutions in which electronegative element is less electronegative element is present, or polar group is absent, are form ideal solutions. So, I give you a trick how to solve or how to get the answer. Those compounds in which polar group absent are form ideal solutions. Here, my dear students, you can see here this is a polar group is absent, here this is the polar group is present, here absent. So, my dear students, D is the correct answer, because in this compound polar group is, and COH group is a polar group here present. So, it is not form ideal solutions. Now, we can go to the question number 27. An ideal solution is formed when its components, here my dear students, we can see the ideal solution is formed when its components same characteristics are present, have no volume change on mixing, have no enthalpy change on mixing, have both the above characteristics, means volume delta V is equal to 0, delta H is equal to 0 are from the ideal solutions. So, my dear students, you can go to the question number 27 option C.